In the spring of 1942 at Fort Knox, Kentucky, a pivotal moment unfolded for battlefield communications. Two engineers stood 8 miles apart, each holding a prototype radio that promised to permanently alter how soldiers communicated in the field. The FM gamble pays off. Daniel Noble, the director of research for Galvin Manufacturing Corporation, initiated the test. He pressed the transmit button on his prototype and spoke into the handset. Using frequency modulation, FM technology, his voice traveled through the air, reaching his colleague, Henry Magnuski, 8 miles away. Magnuski heard every word with perfect static-free clarity. The Army's minimum range specification was 3 miles, but Noble's team had just demonstrated more than double that distance during prototype testing. This achievement was even more remarkable, considering the Army had initially mandated amplitude modulation, AM, technology for all portable radios. Noble, however, had successfully convinced them to gamble on FM instead. He had argued that AM was fundamentally unsuited for the rigors of battlefield communication. This technical conviction was about to yield a tactical advantage that would significantly contribute to winning World War II. The SCR-300 walkie-talkie they were testing was designed to provide reliable communications over 3 miles in operational use, with a potential range of up to 5 miles in optimal conditions. This represented a 3-fold improvement over existing handheld infantry radios. This communication edge would prove so overwhelming that one general later called it the single most useful piece of communications equipment employed in the European theater. This is the chronicle of how a single engineer's unwavering belief in superior radio technology materially contributed to the Allied victory and revolutionized battlefield communications. The genesis of a breakthrough. The journey to that breakthrough demonstration in Kentucky began in September 1940. That's when Daniel Earl Noble walked through the doors of Galvin Manufacturing Corporation in Chicago to assume the role of Director of Research. Born on October 4, 1901, Noble was a seasoned engineer, having earned his degree from the University of Connecticut. He'd already made a name for himself by designing the nation's first statewide 2-way FM radio communication system for the Connecticut State Police, which was completed in 1940. He deeply understood the power of FM, its clarity, noise rejection, and reliability in the face of the electrical interference that routinely crippled AM systems. Noble joined Galvin Manufacturing at a tumultuous time in American history. War had engulfed Europe, with France falling to Nazi Germany in June 1940. While the Royal Air Force fought the Battle of Britain, Britain stood alone against the Third Reich. Enduring the Blitz, though officially neutral, military involvement seemed inevitable to those paying attention. President Roosevelt was already accelerating a military buildup. The Army was scrambling to modernize its equipment, doctrine, and training for a war on an unimaginable scale. Among the most critical deficiencies was battlefield communications. Modern mobile warfare required unprecedented coordination across vast distances and among huge numbers of units. Infantry squads needed reliable communication with battalion and company headquarters. Forward observers required speed and precision to call in artillery fire. Tank commanders needed to coordinate with infantry support. Commanders at every level had to issue orders rapidly and maintain situational awareness as tactical situations evolved. The inadequacy of existing radio technology. The radios available in 1940 were simply woefully inadequate for these demands. Earlier attempts at portable infantry radios in the late 1930s, the SCR-194 and SCR-195, had been dismal failures. They used temperamental, unreliable, primitive, super-regenerative circuits and operated on AM frequencies. This meant that every thunderstorm, every vehicle engine, every electrical motor, and every piece of electrical equipment generated interference and static that drowned out vital communications. Radio unreliability had led infantry officers to become deeply cynical about the technology, often preferring to rely on runners carrying messages by hand, despite the risk of messages arriving too late or runners being wounded or killed. Galvin Manufacturing had already achieved some success with the SCR-536 handheld radio, nicknamed the Handy Talkie, a project driven by Chief Engineer Don Mitchell. Impressed, the Army awarded the company a production contract, and the Secret Service was reportedly using the handy-talkie to protect President Franklin Roosevelt even before America officially entered the war at Pearl Harbor. The SCR-536 was a genuine innovation for its era, truly handheld, compact, with the earphone, microphone, antenna, and batteries all integrated into a single 512lb case a soldier could operate with one hand. It operated on high-frequency AM, 3500 to 6000 kilocycles, and was crystal-controlled for stability, an improvement over earlier designs. However, the SCR-536 had a crippling limitation that no amount of engineering refinement within its basic design could overcome. Its maximum effective range was approximately 1 mile under good conditions. This was adequate for communications within a platoon or between a company commander and his relatively close platoon leaders, but it was completely useless beyond that limited range. Infantry companies could not talk to battalion headquarters several miles away. Forward observers couldn't direct artillery fire from observation posts miles away from the batteries. Tank platoons couldn't coordinate with infantry companies during combined arms operations. The 1 mile range created a gaping hole in the military's ability to command and control forces across the distances required by modern mobile warfare. Noble's risky advocacy shortly. After Noble joined Galvin Manufacturing in September 1940, he and Don Mitchell traveled to Fort Monmouth, New Jersey, to present the handy-talkie to the Army Signal Corps for evaluation. Among the officers present were 2 men who would play critical roles in the development of longer-range portable radio communications. Colonel Roger B. Colton, Director of Signal Corps Laboratories since 1938, and Major James Dunn O'Connell, who served as the laboratory's executive officer and would soon head radio communications projects. While pleased with the handy-talkie's design and performance, the Signal Corps officers made it clear that they needed substantially greater range, a portable radio that could still be operated and carried by an infantryman in combat, bridging the gap between company and battalion, and reaching higher headquarters 5 or even 10 miles away. Facing this requirement in 1940, the Signal Corps chose to contract for the development of a new portable AM transmitter receiver. The decision to specify AM technology was understandable. AM was a proven, established technology. The military trusted AM, knew AM, and had built its entire communications infrastructure around it. Operators and maintenance personnel were trained on AM equipment, and the logistics system was designed to support it. AM was the conservative, safe choice. When Noble learned of this decision during meetings in Washington, his response was immediate, forceful, and risky. He told Major O'Connell that contracting for an AM portable radio was a grave mistake. Noble insisted that the area of development should be for an FM portable unit. This was an extraordinarily bold stance to take with military procurement officials. He was essentially telling the Signal Corps they were making a fundamental technical error, contradicting the preferred technology of the military establishment, and advocating for a solution that was potentially more expensive and complex. He was asking them to take a chance on a technology that many radio engineers considered impractical for portable military applications. AM was familiar. FM was newer, exotic, and less proven in military applications. Noble's opponents had good arguments. FM circuitry was more complex than AM, raising concerns about reliability in the field and maintenance. FM also required wider bandwidth than AM, meaning fewer channels could fit into any given frequency allocation, a serious drawback when radio spectrum was considered a scarce resource. The inherent advantages of FM, however, Noble grasped a fundamental truth that many engineers of the era did not fully appreciate. FM offered genuine, fundamental advantages that would far outweigh its complexity and cost in battlefield applications. Noise rejection. FM inherently rejected electrical interference and noise in ways AM simply could not. Clarity at range. FM provided clear voice transmission even at the limits of its range, while AM signals faded into progressively worse noise and static as the range increased. Hostile environments. FM would work near electrical equipment and running vehicle engines in the electromagnetically hostile environment of a battlefield, conditions that would render AM radios nearly useless. Noble had seen this, demonstrated in his Connecticut State Police FM system. His technical expertise and proven track record, combined with his passionate arguments, carried the day. Major O'Connell, convinced, issued a Signal Corps contract for the development of an FM portable transmitter receiver to Galvin Manufacturing Corporation. The designation assigned to this new radio would be the SCR-300, Signal Corps' radio number 300. With that contract, Noble and his team embarked on one of World War II's most challenging and ultimately most successful engineering projects. Engineering the walkie-talkie. Back in Chicago, Noble quickly assembled a core team of Galvin Manufacturing's brightest minds. Henry Magnuski, an immigrant from Poland and a future distinguished engineer, would serve as the principal RF engineer, responsible for the critical radio frequency circuits. Lloyd Morris, Marion Bond, and Bill Vogel rounded out the core team, each bringing specialized expertise. The Army's specifications for the SCR-300 were extraordinarily demanding: power. Battery-powered with sufficient energy capacity for useful field operation without frequent changes. Weight: no more than 35 lbs, complete with accessories and batteries. Light enough for an infantryman to carry on his back while still fighting. Range: reliable communication over a distance of at least 3 miles in varying terrain, over hills, through forests. Ruggedness: water-resistant and able to withstand rain. Humidity and general field moisture. Usability: simple enough for minimally trained soldiers to operate effectively under the stress of combat. Tuning: continuously. Tunable across a range of 40 to 48 MHz to provide multiple channels. Crystals: critically, it had to use only 2 frequency control crystals, due to crystal production being a wartime bottleneck. Meeting all these specifications simultaneously seemed almost impossible, but the team had one enormous advantage: FM technology, whose inherent characteristics helped solve several of the most difficult problems. One morning in late 1940, Noble assembled Magnuski and a young engineer, Andy Affronti. He placed the official Signal Corps specification document on the bench and read the requirements aloud. Finishing, he delivered a line that burned into the memories of both engineers. "Henry and Andy, I want you to start working on this immediately." They placed a life and death priority on this program for the infantry. Driven by the knowledge that soldiers' lives depended on their success, Noble's brilliant team developed a design that was revolutionary in several ways. Single tuning control. They created a single control to tune both the receiver and the transmitter simultaneously, dramatically simplifying operation for the soldier in the field. Automatic frequency control, AFC. AFC circuitry was incorporated to lock onto the correct frequency and maintain it without drift, ensuring clear communication without requiring constant, precise tuning, a task unrealistic for a combat soldier under fire. Power efficiency. They designed circuits that could operate efficiently on battery power while still delivering adequate receiver sensitivity and transmitter output power, overcoming the limits of primitive 1940s battery technology while keeping the weight down. Tropicalization. Components were treated with special coatings to withstand the humidity and tropical temperatures of the Pacific Theater. Squelch circuit. An adjustable squelch circuit. A new feature for military radios was incorporated. On AM radios, operators had to listen to constant hissing and crackling noise when no one was transmitting, leading to mental fatigue and missed messages. The squelch silenced the receiver when no signal was present, making it immediately and arrestingly obvious when a transmission came through. Two-crystal solution. They overcame the two-crystal limitation by using harmonic relationships and careful frequency synthesis to generate all the necessary frequencies for the 41 channels from just 2 crystal references. Relay capability. The radio could be set up for relay or retransmission operation, allowing 2 SCR-300 units to double or triple the communication range far beyond the line of sight. Invaluable in mountainous terrain. The final SCR-300 design was an 18-tube, battery-operated VHF battlefield radio using FM transmission, the ultimate validation at Fort Knox by spring 1942. After more than a year of intensive engineering, Magnuski and Affronti had 2 working prototypes ready for testing. At Fort Knox, 8 miles separated them, far exceeding the 3-mile operational specification. Magnuski, on the flat roof of the Tropic Air Building, keyed the transmit button. 8 miles away, Affronti heard the transmission with perfect clarity. Formal Signal Corps evaluations followed days later, leading to immediate approval to proceed with production development. The final production version, designated BC-1000, the radio unit, and comprising the complete SCR-300 walkie-talkie system with accessories, came in slightly over the original 35 lb specification, approximately 38 lbs with the larger battery. But the Army accepted the additional weight as a reasonable trade-off for the radio's exceptional reliability and performance. The final acceptance tests were held at Fort Knox, home of the Armored Force School, in the surrounding fields, woods, and rolling hills. The Infantry Board, a highly critical body that had rejected numerous pieces of equipment over the years, was invited as observers. Bob Galvin, son of company founder Paul Galvin, accompanied Noble and Bill Vogel for these critical trials. The SCR-300's performance exceeded everyone's expectations. It communicated clearly through interfering ignition noise from vehicles, proving FM's theoretical resistance to electrical interference translated into real operational advantages. It continued to function after being subjected to rough handling, drops, and exposure to rain. The rugged quality of its design was evident. The Infantry Board officers, tired of manufacturers' unfulfilled claims, responded with uncharacteristic enthusiasm. The radio worked as advertised, even in conditions that would have crippled AM radios. The Signal Corps placed orders for production. Galvin Manufacturing Corporation, which officially changed its name to Motorola in 1947, went on to produce nearly 50,000 SCR-300 units during the war. The first production units were rushed by air transport to combat theaters. Such was the urgency to overcome the severe communications problems experienced in the North African and Sicilian campaigns. Triumph in the Pacific Theater. SCR-300 made its combat debut in the Pacific Theater, specifically on the volcanic island of New Georgia in the Solomon Islands in August 1943. It supported operations in some of the most challenging communications terrain imaginable. Colonel Ankenbrandt, the theater signal officer, was initially deeply skeptical about the SCR-300's suitability for jungle operations. His skepticism was soundly reasoned. Thick jungle vegetation scattered and absorbed radio waves, and the mountainous terrain of the islands created dead zones and radio shadows, all factors that argued against VHF operation. He had actually protested the decision to replace the SCR-511 with the SCR-300. However, once the SCR-300 arrived and troops began using it in combat, Ankenbrandt completely changed his assessment. By January 1944, he was sending enthusiastic reports to General Meade, stating that the SCR-300 sets were exactly what is needed for frontline communications in this theater. This phrase, coming from a highly skeptical signal officer, was a powerful vindication of Noble's technical choices. The main operational complaint was a logistical one: keeping the radios supplied with fresh BA-70 and BA-80 batteries, which had a limited life in the high heat and humidity of the Pacific. This was a supply problem, not a design flaw. The communications capability the radio provided was exactly what frontline commanders needed to effectively control their units in the confused, close-quarters fighting of jungle warfare. Second Lieutenant Joseph Dooley, communications officer of the 298th Infantry Regiment, provided crucial operational feedback, while noting minor complaints about the harness design, which distributed the 30-plus pound load poorly and caused fatigue. Dooley concluded his formal report by calling the SCR-300 an infantryman's dream for better communication and control of troops by radio than ever before given us. The radio worked under fire, in the field, and gave infantry commanders a capability they had never possessed. Earlier versions of the SCR-536 handy-talkie had rapidly failed in the jungle due to corrosion and fungus, sometimes lasting only 36 hours. The Signal Corps had responded by developing specialized tropicalization treatments, including fungus-inhibiting shellac. The birth of the walkie-talkie, FM's role in World War II, victory in spring 1942 at Fort Knox, Kentucky, a moment that would fundamentally alter battlefield communications took place. Two engineers stood 8 miles apart. each in possession of a prototype radio destined to change military operations forever. Daniel Noble, the research director at Galvin Manufacturing Corporation, initiated the transmission. Speaking into the handset of his prototype, his voice traveled using frequency modulation, FM technology, arriving crystal clear and static-free. Henry Magnuski, his colleague, heard every word with perfect clarity 8 miles distant. Noble's team had just demonstrated more than double the minimum 3-mile range required by the Army. What made this feat even more remarkable was that the Army had initially mandated amplitude modulation, AM, technology for all portable radios. Noble, arguing that AM was fundamentally unsuited for battlefield communications, had convinced them to gamble on FM instead. This calculated risk was about to be instrumental in achieving victory in World War II. The SCR-300 walkie-talkie they were testing would deliver reliable communication over 3 miles in operational use, with the possibility of up to 5 miles in optimal conditions. This was a 3-fold improvement over existing handheld infantry radios and would provide American troops with such an overwhelming communication advantage that one general would later declare it the single most useful piece of communications equipment employed in the European theater. This narrative tells how one engineer's insistence on superior radio technology revolutionized battlefield communications and contributed materially to the Allied victory, from Connecticut to Chicago. Noble's FM Foundation. The journey toward this breakthrough in Kentucky started in September 1940. The moment Daniel Earl Noble arrived at Galvin Manufacturing Corporation in Chicago as its new director of research. Noble, born October 4, 1901, and an engineering graduate of the University of Connecticut, had established his reputation by designing the nation's first statewide two-way FM radio communication system for the Connecticut State Police. Completed in 1940, he understood FM's capabilities, reliability, clarity, and noise rejection in the presence of electrical interference that typically crippled AM systems. Noble's arrival at Galvin Manufacturing coincided with a pivotal moment in American history. War had engulfed Europe.
France had fallen to Nazi Germany in June 1940, while the Royal Air Force fought the Battle of Britain.
Britain stood alone, enduring the Blitz. Though the U.S. remained officially neutral, military involvement seemed inevitable. President Roosevelt had begun a military buildup that would accelerate dramatically over the following year. The Army was scrambling to modernize its training, doctrine, and equipment for a conflict of unforeseen scale. Among the many deficiencies the military faced, battlefield communications ranked as one of the most critical. Modern warfare demanded coordination across unprecedented numbers of units and over unprecedented distances. Infantry squads required reliable ways to communicate with company and battalion headquarters. Forward observers needed to call in artillery fire with speed and precision. Tank commanders had to coordinate with supporting infantry. At every level, commanders required the ability to maintain situational awareness and rapidly issue orders as tactical situations evolved. The AM dilemma and Noble's bold challenge. The radios available in 1940 were simply woefully inadequate for these military demands. Attempts at portable infantry radios in the late 1930s, the SCR-194 and SCR-195, had been dismal failures. Operating on AM frequencies with primitive, temperamental, super-regenerative circuits, interference from every vehicle engine, electrical motor, and thunderstorm routinely drowned out vital messages. So unreliable were the radios that infantry officers became deeply cynical about radio communications, often preferring runners carrying messages by hand, despite the risk of messages arriving too late or runners being wounded. Galvin Manufacturing had already found success with the handheld SCR-536, nicknamed the Handy Talkie, a development driven by Chief Engineer Don Mitchell. Impressed, the Army awarded a production contract, and the Secret Service was reportedly using it for presidential protection even before Pearl Harbor. The SCR-536 represented genuine innovation, a truly compact, handheld unit with the antenna, batteries, earphone, and microphone integrated into a single 512LB case, operable with one hand. It used crystal-controlled high-frequency AM, 3,500 to 6,000 kilocycles, an improvement over prior designs. However, the SCR-536 had one crippling, unfixable limitation within its basic design, a maximum effective range of only about 1 mile under good conditions. This was sufficient for communication between a company commander and his platoon leaders, or within a platoon, but it was completely useless for anything beyond that limited range. Infantry companies could not communicate with battalion headquarters several miles to the rear. Forward observers couldn't direct artillery fire from observation posts miles away. This 1-mile range left a gaping hole in the military's capacity for command and control across the distances required by modern mobile warfare. Shortly after joining Galvin in September 1940, Noble accompanied Mitchell to Fort Monmouth, New Jersey, to present the handy-talkie to the Army Signal Corps. Present that day were Colonel Roger B. Colton, Director of Signal Corps Laboratories since 1938, and Major James Dunn O'Connell, who would soon head radio communications projects. While impressed with the handy-talkie, the officer stressed the need for something with substantially greater range that an infantryman could still operate and carry in combat, bridging the communications gap between battalion and company. The SCR 300 contract and design hurdles facing this requirement in 1940, the Signal Corps chose to contract for the development of a new portable AM transmitter receiver. The decision to specify AM technology was understandable. AM was established, proven, and the military had built its entire communications infrastructure, training, and logistics around it. AM was the conservative, safe choice. When Noble learned of this decision, his response was immediate, risky, and forceful. He informed Major O'Connell that contracting for an AM portable radio was a grave mistake. Noble insisted that development must focus on an FM portable unit. This was an extraordinarily bold stance, contradicting the military establishment's preferred technology and advocating for a potentially more complex solution. Noble was asking the Signal Corps to take a chance on a technology many radio engineers doubted for portable military applications. AM was familiar. FM was less proven. Arguments against FM included its wider bandwidth, meaning fewer channels in a given frequency allocation, and its more complex circuitry, raising concerns about field reliability and maintenance. But Noble understood the fundamental advantages that would far outweigh FM's complexity on the battlefield. FM inherently rejected electrical interference and noise in ways AM could not. It provided clear voice transmission, even at maximum range, unlike AM, which faded into progressively worse static. Noble's conviction, backed by his track record, was persuasive. Major O'Connell, convinced by the technically grounded argument, issued a Signal Corps contract to Galvin Manufacturing Corporation for an FM portable transmitter receiver. It was designated SCR 300, Signal Corps Radio Number 300. Noble quickly assembled a team, including Henry Magnuski as the principal RF engineer, along with Lloyd Morris, Marion Bond, and Bill Vogel. They faced extraordinarily demanding specifications, a maximum weight of 35 lbs, including accessories and batteries, reliable communication over at least 3 miles across varying terrain, water resistance, ease of operation for minimally trained soldiers, and tuning across the 40 to 48 MHz range, all while using a maximum of only 2 frequency control crystals. Engineering triumphs and combat performance. Facing a challenge with life and death priority, Noble's team developed a design that was revolutionary. They created a single tuning control to tune the transmitter and receiver simultaneously, simplifying use under stress. Automatic frequency control, AFC circuitry was incorporated to maintain frequency stability without requiring constant, delicate tuning from the operator. They also overcame the power challenge by designing highly efficient circuits to maximize battery life, while maintaining adequate power output and receiver sensitivity. The final SCR 300 design was an 18-tube, battery-operated VHF battlefield radio using FM. It incorporated a groundbreaking feature for military radios, an adjustable squelch circuit. This silenced the receiver when no signal was present, saving operators from the mentally fatiguing hiss and crackle of AM radios and making incoming transmissions immediately obvious. The 2-crystal limitation was elegantly solved by using harmonic relationships and careful frequency synthesis to cover all 41 channels. The entire radio could also be set up for relay or retransmission operation, potentially doubling or tripling the communications range. The testing in spring 1942 proved the prototype's flawless performance. Formal Signal Corps evaluation followed, leading to production approval. The production system, weighing approximately 38 lbs with the larger battery, was accepted by the Army as a reasonable trade-off for its exceptional performance. The Infantry Board, a highly skeptical body, observed the final acceptance tests at Fort Knox. The SCR-300 exceeded all expectations, communicating clearly through the ignition noise of vehicles and holding up under rough handling, rain, and drops. The rugged mechanical and electrical design was evident. The Infantry Board's approval, carrying immense weight, was secured. Galvin Manufacturing, later Motorola, went on to produce nearly 50,000 SCR-300 units during the war. The first units were rushed to combat zones due to severe communications problems in the North African and Sicilian campaigns. Tactical. Dominance in Europe and the Pacific. The SCR-300 made its combat debut in the Pacific Theater on the volcanic island of New Georgia in the Solomon Islands in August. 1943, Colonel Ankenbrandt, the theater signal officer, was initially deeply skeptical, believing VHF radios would not work in dense jungle, where vegetation scattered radio waves and mountainous terrain created dead zones. However, the FM radio's performance surprised everyone, including the skeptical signal officer. By January 1944, Ankenbrandt was enthusiastically reporting the sets were exactly what is needed for frontline communications in this theater. The tropicalized SCR-300 sets proved dramatically more durable, lasting for weeks or months in the harsh tropical environment. Unlike earlier radios that failed in days, the SCR-300 saw its first European use during the invasion of the Italian mainland in September 1943. Radio operators waded through the surf under fire and immediately established communication networks. In the initial chaotic hours, the radio's value was dramatically apparent. Company commanders could talk directly to battalion headquarters several miles to the rear. Forward observers, receiving the SCR-300 in significant numbers, could now call for artillery fire with unprecedented reliability and speed. The FM signal cut through the electrical noise and interference of the battlefield, allowing coordinates to be transmitted and confirmed swiftly, reducing fire missions from many minutes to a fraction of the time. The radio was literally worth its weight in gold. It allowed commanders to call for immediate reinforcement, and defenders to call in concentrated artillery barrages to break up counterattacks. Lieutenant Joseph Dooley called the SCR-300 an infantryman's dream for better communication and control of troops. By June 1944, on the beaches of Normandy, France, thousands of SCR-300 radios were carefully packed for Operation Overlord. The lessons from Italy and the Pacific had been fully absorbed. Amidst the chaos and massive electromagnetic noise from hundreds of running engines on the invasion beaches, the SCR-300's FM signal cut through all interference as if it didn't exist. Forward observers could direct naval gunfire from cruisers and battleships against German strong points. The relay or retransmission capability became critically important in the bocage, hedgerow, country of Normandy. 2 SCR-300 units could automatically relay transmissions, extending communications well beyond line of sight across difficult terrain. This capability, combined with AFC and crystal-controlled tuning, worked reliably even when relay stations were operated by soldiers under fire. Emergency requisitions just 15 days after D-Day for additional units demonstrated the recognition that the SCR-300 was an essential combat multiplier. The Bulge, and a lasting legacy in the Battle of the Bulge in December 1944. During Hitler's last desperate offensive, the SCR-300 proved its greatest value in the European theater. In the chaos and miserable sub-freezing weather, with units scattered, cut off, and surrounded, the radio provided a lifeline. It allowed surrounded units to coordinate movements, organize withdrawals, establish new defensive lines, and call for supplies and reinforcements despite being physically isolated. Artillery forward observers could continue to call fire missions, allowing rapid massing of artillery fire to stop German armored spearheads. Without the reliable communication provided by the SCR-300, the defense of Bastogne would have been vastly more difficult. After the battle, Many officers felt the SCR-300 was perhaps the single most useful piece of communications equipment employed. The SCR-300 gave Allied forces a communication superiority over their enemies,
whose systems primarily still relied on AM technology and whose portable radios were often less reliable.
Heavier or required cumbersome hand-crank generators. The self-contained, single-operator SCR-300 was a significant tactical and technical advantage. The SCR-300's impact extended far beyond World War. It was a crucial proof of concept for FM technology and military applications, shaping decades of post-war communications development. Major General Roger B. Colton recognized the long-term significance of the decision to adopt FM, with FM inventor Edwin Howard Armstrong calling it the most difficult decision of the history of radio which anyone was ever called upon to make. The SCR-300, later superseded by lighter transistor-based FM radios like the AN-PRC-10 and the PRC-2577 that served in Vietnam, established fundamental design principles that remain standard in military portable radios today. The increase in reliable range from the handy-talkie's 1 mile to the SCR-300's 3 Tier 5 miles represented a transformative change in how infantry units could be coordinated and commanded. This extended range allowed for more flexible and aggressive tactics, executed with confidence that communications would be maintained. The psychological impact on soldiers, knowing support was a reliable radio call away, also significantly boosted morale and combat effectiveness. The story of the SCR-300 is one of technical courage, innovation against institutional resistance, and the willingness to pursue a better way that ultimately saved countless lives and contributed to victory. Technical courage, an enduring legacy Noble, was advocating for a more expensive and potentially more complex technological solution when the simpler, cheaper option seemed adequate to the procurement system. He was essentially asking busy military officers to trust his technical judgment over the organization's established practices and their own institutional preferences. But Noble grasped something others didn't fully realize at the time. Ontex FM dollars offered genuine fundamental advantages in battlefield communications that would fully justify the additional cost and complexity. He knew that clear voice transmission at the limits of range could mean the difference between successful coordination and catastrophic confusion. He understood that soldiers fighting in the electromagnetically hostile environment of modern mechanized warfare desperately needed communications that would work reliably despite massive electrical interference. He was willing to stake his professional reputation on these convictions, and his willingness to take that risk and fight for the right solution paid off in ways that helped win the war and saved countless lives. A life and death priority. Engineering team turned Noble's vision and advocacy into working hardware, solving the enormous technical challenges involved in creating a battery-powered hard-text FM dollar portable radio that satisfied all of the Army's demanding specifications. They demonstrated the kind of practical, urgent, and focused innovation that characterized American industrial mobilization and engineering at its finest during World War II. When Noble had placed that specification sheet before Affronti and Magnusky, telling them it was a life and death priority for the infantry, he wasn't exaggerating for dramatic effect. He was stating a literal truth. Soldiers' lives depended on this radio working reliably in combat. The team understood the weight of that responsibility, and they delivered results that exceeded the Army's expectations and specifications. When Henry Magnusky and Daniel Noble stood 8 miles apart in the Kentucky fields in the spring of 1942, testing their prototype text FM radio and achieving crystal-clear communications far beyond the 3-mile requirement, they knew they had created something technically significant. However, neither could have fully predicted the enormous scale and scope of that success and the impact their radio would have on subsequent military communications development and the war itself. A war-winning advantage, the SCR-300 would be used in every theater where American forces fought during World War II. It served in the mountains of Italy, in the hedgerows of Normandy, on the volcanic islands of the Pacific, in the final drive across Germany, and in the jungles of the Philippines and New Guinea. It was carried by infantry privates slogging through jungle and mud. It was used by special operations forces operating behind enemy lines, by airborne troopers jumping into hostile territory, by Marine raiders hitting hostile beaches, by tank commanders coordinating combined arms operations, and by artillery forward observers calling fire missions from exposed positions. The SCR-300 saved countless lives by maintaining command and control, preventing units from blundering into friendly fire situations or ambushes, by enabling timely and accurate artillery fire, breaking up enemy attacks before they could succeed, by allowing isolated units to call for and receive reinforcements. In time, it contributed to victory by giving Allied and American forces a decisive advantage in coordination and battlefield communications. After the war, the SCR-300 served as the foundation and proof of concept for generations of improved military radios that continued to refine and use the FM principles Noble's team had successfully combat-proven. Each successive generation of military portable radios built directly on the lessons learned from the SCR-300, retaining the fundamental FM approach while incorporating new technologies like integrated circuits and transistors, an enduring testament to improvement in battlefield communications capability represented by the SCR-300 was far more than just a technical achievement noted in military catalogs or engineering journals. It was a war-winning advantage that gave Allied and American forces a decisive superiority in their ability to coordinate, control, and command forces on the battlefield. This communication superiority translated directly into operational and tactical advantages that helped defeat the Axis powers and win the war. That decisive advantage stemmed from one engineer's clear technical vision and his courage in advocating for it against institutional resistance, one brilliant engineering team's successful execution of an enormously challenging development program, one company's willingness to embrace innovation and take on difficult challenges despite an uncertain outcome. The SCR-300 stands as an enduring testament to what determined innovation, technical insight, and engineering excellence can achieve when applied to problems where success literally means the difference between victory and defeat, between life and death. Today, more than 8 decades later, we still benefit from the legacy of Daniel Noble's revolutionary radio and his unwavering determination to provide American soldiers with the very best communications technology that manufacturing capability and engineering skill could provide. The story of the SCR-300 serves as a reminder that courage in challenging conventional wisdom, technical innovation, and excellence in execution can change the course of history. Do you have another video script you'd like me to paraphrase? Or perhaps a different task related to this topic?